This video describes new P' and U' control charts that have been added to Statgraphics Centurion version 17. P' and U' control charts monitor attribute data by plotting proportions and rates. They're similar to P charts and U charts, except that they do not assume that nonconformities occur completely randomly. If nonconformities tend to occur in clusters, then the counts will be overdispersed compared to binomial and Poisson distributions. If you try to plot overdispersed counts on a P chart or a U chart, you'd find many points beyond the control limits. If nonconformities tend to occur in some more regular pattern, then the counts will be underdispersed compared to the binomial and Poisson distributions. In that case, you won't get alarms even if the process is not in a state of statistical control. Statgraphics version 17 provides new tests in the P chart and U chart procedures to determine whether the usual binomial and Poisson models are acceptable. If not, it provides alternative P' and U' charts to handle either overdispersion or underdispersion. The P' and U' charts are often called Laney control charts after David Laney, who first talked about them in his text, Improved Control Charts for Attributes. The data we're going to look at is from Hung at Iowa State. It's in a file named internetaccess.sgd and contains the number of attempts to access the internet on 20 consecutive days. The file also shows, out of those attempts, how many times errors were encountered. I've loaded the data into the Statgraphics datasheet. I'm going to start by doing a standard P chart of this data. To do that, I'll go to SPC, Control Charts, Basic Attributes Charts, P chart. I need to specify in the first field the proportions that I want to plot. That will be errors divided by attempts. I also need to specify the sample sizes, that's attempts, and press OK. I'll be offered the option of either plotting a Phase 1 initial studies control chart, where the data determine the control limits, or a Phase 2 control to standard chart, where I specify the control limits. I'll stick with an initial study and press OK. When the list of tables and graphs appears, I'm going to add the diagnostic plot and press OK. Let's double-click in the upper right corner to enlarge the P chart. Here you see that the control limits are very, very tight. That's because of the very large sample sizes. The points, although they look fairly stable, except possibly for this one here, have no hope of staying inside those control limits. That's very typical of such large sample sizes. In fact, the average sample size here is over 400,000. If you look at this table here, you'll see how close the control limits are to the center line. There's a second chart that I created called the P chart diagnostic, which is new in version 17 and designed to tell me whether the data can be appropriately modeled by a binomial distribution and therefore charted on a P chart, or whether I should use one of those Laney P' charts. The diagnostic plot calculates something called a variation ratio test. It starts by applying an arc-sine transformation and then plotting the transformed counts on a normal probability plot. It takes the middle 50% of the observations on that plot and fits a least squares regression line. The slope of the regression line is used to estimate the observed variation in the data. It then calculates a ratio comparing the observed variation to the expected variation. If the ratio is less than 60%, that's an indication that the data are underdispersed compared to the binomial. If the ratio is greater than the 95% upper confidence bound that's displayed, it indicates overdispersion. Let's go back and take a closer look at that diagnostic plot. Along the horizontal axis, you see the transformed counts. The vertical axis is scaled such that if the transformed counts follow a normal distribution, the points should lie close to this line. They don't. You obviously see a couple points well off the line, and the slope of the points is considerably greater than the fit. At the top, you see the estimated ratio of the observed to expected variation. It's over 3,700%. The 95% upper limit expected of that ratio is 159%. Any variation ratio greater than 159.362% would in this case indicate overdispersion in the data. It's now time to plot a p-prime chart. To do that, I'll go to SPC, Control Charts, Basic Attributes Charts. This time, instead of the p-chart, I'll plot the p-prime chart. The data is the same as it was for the p-chart. It's errors divided by attempts in the first field, attempts in the second field. The options for the p-prime chart are the same as they were for the p-chart, either initial study or control to standard. I'll take all the defaults, and now you see the p-prime chart. Like the p-chart, it plots the proportions of errors on each day, but the control limits are considerably wider. You can see still that there are some signals that this process may not be completely in a state of statistical control. There's one point on day 4 that's beyond the upper 3 sigma limits. There are also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points in a row, all below the center line. Both of those are unusual events. Other than that, though, you can see that by and large, most days now fall within the control limits. There are a couple other things I should point out about the p-prime chart. The first is the quantity here, sigma sub z. Sigma sub z is an estimate of how much additional variation there is in this data over and above what I would expect if the data came from a binomial distribution. This parameter is important because if I go to Analysis Options and decide I want to do a control to standard, I need to specify not only the location of the center line through p prime, but the value of sigma sub z. These values would normally have been determined from some previous study. Secondly, I don't have to use the average subgroup size if there are significant differences between the sizes of my subgroups. If I turn that check mark off and then replot the data, you'll see that it will now plot control limits based on the actual subgroup size. Finally, I can push the right mouse button and select Pane Options, and then choose Color Zones if I want to color my zones green, yellow, and red. The P' chart and the U' chart, which works in a very similar fashion when you're dealing with rates, are important enhancements to Statgraphics' extensive collection of control charts.